Hello everybody and welcome to the 1.10 KE and PE math lesson. So today we're going to cover the lesson, but don't forget that you will be submitting your science notebook at the end of the unit for the Part 2 test. So you want to complete the slide that goes along with this lesson in your science notebook. So if you struggle with note taking, listen for the parts of the lesson that I tell you to add to your note pages. And I'll be covering the guiding questions as well, so be sure to jot down those answers. If you need to pause the recording and write everything down, then pick it up again. That way you make sure you get everything answered. So as we move into the lesson today, I want to remind you, please make sure every time you work in the course that you open up the science course, click on content, and look down the page here to make sure that you have check marks by all of the things on the left. Make sure that you are not leaving any numbers and that you're completing every lesson, not skipping over any lesson. So all of these should have check marks. So as we get down to 1.10, we are going to take a look, starting with the lesson introduction. All right, so we're talking today about calculating energy. So this is almost going to feel like a math lesson for you. But studying energy involves determining the amount of energy an object has. This energy can be kinetic or potential, or it could be a combination of both. In this lesson, you'll practice deciding what kind of energy an object has, and you'll calculate its kinetic and potential energy. So this lesson is really important that you learn how to work through the problems that we're going to be solving, because you'll be using these formulas in your lab later in this unit. So we only have 2 guiding questions, and I just take a little screenshot of those and put them over to the side, so I make sure that we cover all of those as we go through. And the first page in the lesson is going ahead and jumping right in with those formulas. And you can hear my dog snoring in the background, so I apologize. She thinks that this lesson is a little boring. So problem solving with kinetic and potential energy. The objects in this lesson's problem will only have gravitational potential energy. So every time we calculate anything in this lesson or unit, we're really looking at GPE. We're not doing anything with elastic potential energy. But know that there are different types of problems and different formulas, the way you'll calculate those. So the goal in the first type of problem is going to be to determine if an object has GPE, kinetic energy, or both. And then you'll find the numerical value of each one. And the goal in the second type of problem is going to be to determine the height or the speed of an object, knowing its GPE or its KE. So we're talking about potential or kinetic energy here when you see those letters. And there are 2 equations that you're going to need here. So the first one is your formula for kinetic energy. So the KE obviously equals kinetic energy. And you are going to take half of the mass, and you're going to multiply it times the velocity squared. And then to calculate potential energy, you're going to use the mass of the object. You're going to multiply it times something we call the gravitational constant, and we'll cover that in a minute. And then you're going to multiply it by the height. So in both equations, M stands for mass. It needs to be measured in kilograms. The speed is shown by V, which is measured in meters per second. And the height is measured in H, which is measured in meters. And lastly, G, remember I told you about that one, it's special. The gravitational constant means it's always going to be this number. So on Earth, gravity is a constant number of 9.8 meters per second squared. This is a unit of measurement, so you don't need to do any dividing or squaring with this. But this number, G, is always going to equal 9.8. So mark that down in your notes as well. All right, so as we move on, we're going to be talking about a Ferris wheel and go through some different scenarios to solve these problems. So once the Ferris wheel is loaded and gets to traveling at top speed, Jessie wants to know how much energy she has. So when at the highest point on the circle, Jessie is 30 meters off the ground. And I encourage you to put these practice problems that we're going through, to write them out. Maybe just take a picture of your work and put it in as your notes. So we're given a height, that's h, of 30 meters. And then the Ferris wheel spins at 5 meters per second. So we now have a v. And then we're looking at how much energy does Jessie, who has a mass of 50 kilograms, have at the highest point of the circle. So now we have a mass, 50 kilograms. Okay, so how do we solve this problem? So first, gather the information. Where is the object? It's 30 meters above ground, so we know it has some height. Is the object moving? If it does, if it is, what is its speed? Yes, we have that. It's 5 meters per second. And what is the object's mass? We know that it's 50 kilograms. So now that we have those answers, does the object have gravitational potential energy? So it does if it has some height off the ground. So yes. So now we're able to plug in our numbers and solve. So we're going to do 50 times 9.8 times 30. And so we know that the answer here is 14,700 joules. So potential energy is calculated in joules. You'll need to remember that, so that'd be good to put in the notes as well. So now, does the object have kinetic energy? Remember, an object has kinetic energy if it's moving. And we know that it's moving 5 meters per second. So then we need to solve for kinetic energy by plugging in numbers here. So we're taking half of the mass and we are multiplying it times the speed, the velocity, squared. Okay, so you need to remember that when you're squaring the velocity, we're squaring 5. So we're not multiplying 5 times 2, we're multiplying 5 by itself. When you square something, you multiply it by itself. So it's 5 times 5. So if you take half of 50, we know that is 25 times 25, and that gives us the answer of 625 joules. So kinetic energy is also measured in joules. So that would be a great example to put in your notes so that you can look at how to solve those problems. So as we move on, we're going to practice another one. And this one says, once the Ferris wheel is loaded and gets to traveling at top speed, Jessie wants to know how much energy she has. When at the highest point in the circle, Jessie is 30 meters off the ground, so we have the same height as last time. The Ferris wheel spins at 5 meters per second at top speed, same as last time. So now how much energy does Jessie have at the lowest point of the circle? Okay, so we're having to factor in something a little bit different. We're now talking about the lowest point. And so if we plug in 0 for height there, we know that would be 0 meters. So where is the object? It's on the ground. It's 0 meters. And then is the object moving? So we know that it is moving. It was 5 meters per second. And so if you think about that, on the ground, it really can't be sitting on the ground moving 5 meters. That's a little confusing, but at the lowest point, it's going to be sitting on the ground 0. So from there, we are able to take into account the mass, 50 kilograms, and we're going to plug those same things in again. So remember, an object has GPE if it has some height off the ground. So if yes, then solve using GPE, that formula. So here we take into consideration 0 meters, so that's going to be 0 joules because there's no height. So does it have kinetic energy? If it's moving, yes, then we use this formula. So we're able to plug in half of 50, so the same thing. It has the same kinetic energy as last time. The height is not a factor in this formula at all. We don't have an H listed anywhere in that formula. So 625 joules, that's still the same kinetic energy. All right, so we're able to move on to another example. So now we're looking at, once the Ferris wheel is loaded and it gets to traveling at top speed, Jessie wants to know how much energy she has. So when at the highest point of the circle, she's 30 meters off the ground, the Ferris wheel spins at 5 meters per second at top speed. And when the ride slows down and the people are let off the ride, Jessie is stuck at the top of the circle, at rest. So how much energy does she have now? So we're changing the components again. Where is the object? It's 30 meters above ground, so she's at the top. Is she moving? It says at rest, so no. So her speed is 0. And then does she have a mass? Yes, 50 kilograms. So now we can use these to complete this part for PE and KE. So does the object have GPE? Remember, it does if it's off the ground. So we're able to plug in 50 times 9.8 meters per second times 30 meters, which is 14,700 joules. So we're plugging in all of those things we were given, and the answer is the same as before. So nothing's changed there. All right, but here, kinetic energy, we know that she's not moving. So we're taking half of 50, which is 25, and multiplying it times 0. So it has 0 joules, 0 kinetic energy at rest. All right, so we've looked at a few scenarios. Let's take a look. This shows you step by step how to solve the problems. There's some different numbers here so that we can take a look at some different examples, and let's see what we can come up with. So it's always great to have these in your notes and to practice so that when you have to solve these for a quiz or a test, you are able to do it. So for step 1, it says find the height. At one point on the Ferris wheel ride, Jessie, who was a mass of 50 kilograms, has 4,900 joules of GPE. How high is she off the ground? So now we've got to practice manipulating that formula a little bit to find the height. So step 2, here is everything we have and what we're looking for. And so our known is the GPE, 4,900 joules, equals 50 kilograms times 9.8. And now we've got to figure out the height. So if you isolate the variable that you're solving, okay, we've still got to multiply this out. So the 50 times 9.8 is 490. So we take that number, 490 here. We're going to divide it over onto the left side of the equation to single out height, and this says 10 meters. So in this problem, she would be 10 meters off the ground. And if you push the button down here, it talks you through how to do that. All right. So another step, if we look at this, here's another way you can solve a problem by pulling out the velocity. So using the kinetic energy formula, it talks about a ball rolling down a ramp. The ball has a mass of 1 kilogram and it has 18 joules of kinetic energy. So what's the ball's speed? So here we've got to plug in what we know and single out what we are looking for. And so we're looking for the speed equals 2 times the kinetic energy divided by the mass. So how do we rearrange that? If you look at it here, this is what it looks like. Okay, so that's how you're able to break that down. So a lot of math involved here, a lot of your math skills. So you're able to get the velocity over on one side, and then you're able to start multiplying. So once you do that, you can see that 2 times 18 is 36. So you have that, and then you remember that this one over here is a formula consisting of kilograms, meters per second squared, and that's going to equal 1 joule. So we've got V2 is equal to 36 kilograms, and then you're remembering all of those things together. That's a lot of stuff, but it's a joule. So you're canceling those things out. You've got to take the square root here. So you can see that you're taking the square root on both sides, 36, and that gives you 6 meters per second. All right, so you're taking out this squared and squared, so it's just single by itself, the square root, and you have a velocity of 6. So I know that one's a little bit more confusing. And then here's your notebook activity. So before we do that, let's take a look back over at the guiding questions. It said, what are the formulas for GPE and KE? So you should easily have those to answer in your guiding questions. You just go back, copy those formulas from the first page. And then how do you determine if an object has gravitational potential energy? So in all of those sample problems we did, if it had gravitational potential energy, we had height. So we were given the height. And if it had kinetic energy, we were given the speed. So sometimes they had both, and sometimes it just had one or the other. So that answers your 2 guiding questions. So now on to the science notebook activity. This is required, so it does need to be in your science notebook. And consider a 2 kilogram bowling ball as it sits on top of a building that is 40 meters tall. So we're given already a mass, so M equals 2 kilograms. Our height is 40 meters. And think about the amounts of potential and kinetic energy the ball has, one as it sits on top of the building, and then as it's halfway through a fall off of a building that's 40 meters tall, and it's traveling at 19.8 meters per second. And then as it's just about to hit the ground, so falling from a building that's 40 meters tall and traveling 28 meters per second. So now we're able to answer these questions. So does the bowling ball have more potential energy or kinetic as it's sitting on top of the building? Okay, so here we know that it's got more potential energy because it has height. So remember, if it's sitting, it's not moving, it has no kinetic energy. So number 2, does the bowling ball have more potential or kinetic energy halfway through its fall, and why? So we would have to calculate that. Halfway through the fall, we need to calculate the kinetic and potential. So if we take, calculate PE, we have a mass of 2 times 9.8 meters per second times the height. So if it's halfway, it tells us that it would be 20 meters. So we multiply those all together. We have 392 joules. That's potential energy. So for kinetic energy, we now have to calculate in the speed. So we have half of 2, so that just gives us 1, times the velocity, which is 19.8 meters per second. So 19.8 squared. So we do that. It gives us 392.04, but basically round that to 392. So we can see that doing that math for question number 2, when we calculated it out, it's the same. It's both, they're equal, 392 joules. So because the height is dropping and the speed is picking up, that's why it's changed. So question 3 says, does the bowling ball have more potential energy or kinetic energy just before it hits the ground? So we would know that its speed before it hits the ground is going to be higher. Its height is almost 0. So it's going to have more kinetic energy because it's going to have more speed. Its potential energy is going to be very low because the height is very low. So on number 4, it says, what is the potential energy of the bowling ball as it sits on the building? So it's on top of the building. So that way we would take, just plug in all those numbers again, 2 times 9.8 times 40. Remember, on top of the building, it's 40. So we get an answer of 784 joules. So that's the answer to number 4. What's the potential energy of the ball halfway through? We've already calculated that. Remember, we did that up here. And it's 392. And then number 6 says, what's the kinetic energy halfway through? And we already did that up here too. And that was 392 as well. So you want to make sure you show that work. Plug in all those numbers so we can see it again. And then finally, number 7, what is the kinetic energy of the ball just before it hits the ground? So the speed here is over here. So we're plugging in 1/2 of the mass of 2. So that's just 1. And then the velocity here is 28 meters per second. So 28 times 28 is 784. So it's the same number that we saw before, but it is same potential energy that was calculated at the top of the building. It's got the same kinetic energy right before it hits the ground. So 784 as well. So that gets you through all the notebook activity questions as well. From there, we'll wrap it up. Make sure that we got through everything we need. So in review, as you wrap up the lesson, a couple of take-home points for you. You can practice some more problems, see if you can solve those on your own. Make sure you have the equations and all that science notebook activity in your notes and in your notebook. And then your next steps for our sessions and what you should do next is just look for our flip follow-up. Remember, coming to class makes just things more interactive. You can ask questions, kind of gives you a bigger picture. But attend Help Lab if you need it, and have a great day.